All right, everyone. So today's schedule, we're going to quickly review quiz number 2, look at chapter 4, working memory, take a quick peek at discussion board number 4, and go over the end of your first research assignment, numerical memory. So for quiz 2, again, I hope you guys didn't find this too difficult. So how can you use prior knowledge to increase your short-term memory capacity? Well, you can chunk information into meaningful bits of information. What are the two primary components of the phonological loop? Subvocal rehearsal and the phonological store. What is the purpose of an articulatory suppression task, like repeating the word the while doing something? That's to keep people from actively rehearsing information in their short-term memory. Which of the following effects of the phonological loop suggests it is better to listen to instrumental music while studying compared to music that has vocals? And that would be phonological similarity. So music with vocals may cause some confusion while you're studying. In serial position curves, the recency effect is attributed to short-term memory, and the primacy effect is attributed to long-term memory. So if you guys have any specific questions about any of those, reach out and just let me know, okay? So today we're going to be talking about Chapter 4, Working Memory. And this is where the author of our textbook and kind of the giant in this field, Baddeley, really comes into play. So we're going to start today by watching a video of Baddeley himself talking about how he developed the working memory model.
After a few years at the Applied Psychology Unit, I moved to a teaching post at the University of Sussex. And my then boss said, "You ought to apply for a grant. Why don't you apply for a grant?" So I applied for a grant to look at the relationship between long-term and short-term memory. And I asked for a postdoc and a research assistant. And they cut the research assistant but allowed me a postdoc. And the person I appointed was Graham Hitch. Now, at that time, short-term memory research had become rather unpopular. It had become very messy. There were many similar models and not much ability to separate them. And there was also some rather, there were two problems with the models. They all more or less approximated to the most influential of these, which was a model by Atkinson and Shiffrin, which became known as the modal model because it was kind of in the middle and like all the others approximated to. And this assumed that information fed through a series of sensory buffers, visual iconic memory, auditory echoic memory, into a unitary store that acted as a working memory. Now, the term working memory had been invented in 1960, but not really used. I think it was first used by Atkinson and Shiffrin, who used it as a label, but didn't actually expand. The idea of a working memory is that it's a temporary memory system that you use in order to help you do other complicated cognitive tasks, so like reasoning, like learning, like comprehending. And the Atkinson and Shiffrin model assumed that it acted as a working memory. There were two problems with it. One was its assumption about learning. It assumed that the more time you held something in this temporary memory, the better you learned it. It didn't matter what you do, just hold it. In fact, it turns out that simply holding it by saying it to yourself, for example, is a very inefficient way of learning. And as Craig and Lockhart demonstrated in their levels of processing paper, the more deeply you think about something, the more deeply you process it, the better you learn it. So if you show somebody a word and just ask them, is it in capital letters or not, they'll remember very little about that word. If you ask them, does it rhyme with the word dog, they'll do a bit better. But if you ask them something about its meaning, is it a pleasant word? Does it fit into the sentence, the man kicked the, then they'll remember it very much better. So that actually disenchanted a lot of people with the original model. As far as I was concerned, one of the crucial problems came from neuropsychology. An important component of the attempt to distinguish between long and short-term memory had come through the study of single-case patients. So, for example, the study by Brenda Milner of patient HM, who had had an operation to treat intractable epilepsy, and this had involved removing tissue from his brain bilaterally on both sides, and in particular from an area called the hippocampus. This resulted in relieving his fits, but making him densely amnesic. But nevertheless, his ability to hear and repeat back a telephone number was fine, so he seemed to have reasonable short-term memory. Some work that I'd done with Elizabeth Warrington in London had expanded this by taking a number of the tasks that had been used to separate long-term and short-term memory in the general cognitive literature and testing these on a group of very pure amnesics. A very pure amnesic is someone who has a dense deficit in the capacity to learn and recall new material, but who is otherwise intact. So their intelligence is fine, their perception, their language, everything is intact, except for this very dense, very precise memory deficit. Now, at the same time, Elizabeth Warrington and Tim Challis studied an exactly complementary case of someone whose long-term memory is fine, but whose ability to repeat back a telephone number was limited to 1 or 2 digits. So one had what was called a double dissociation. One group that could do A but not B, another group that could do B but not A. So that was regarded, and is still regarded, as powerful evidence in favour of a separation between A and B. Now, one prediction that one could make from this, if you use the Atkinson and Shiffrin model, is that the patient with grossly impaired short-term memory should also have a bad working memory and should have difficulty in learning because they assumed that the information came through this working memory. And these patients didn't. Their learning was pretty normal, their language was normal, their intelligence was normal. These are, understand, carefully selected patients. If you just take a patient off the ward and home, then usually brain damage is general, you get a complicated result. But particularly in these early days, we learned a lot from carefully selecting patients that allowed us, in a sense, to do an experiment of nature in which you pull apart 2 crucial variables. Now, by finding this patient who didn't behave according to Atkinson and Shiffrin, this seemed to cast doubt on the whole idea of a working memory. So what we decided to do was to try and tackle the question of what's memory for, what's working memory for. Now, we didn't have access to these rare patients, but what we decided to do instead was to try and take our student subjects and make them into patients. And we did this not by clunking them on the head, but by giving them a task that would use up that part of their brain or that part of their mind. So we said one task that uses short-term memory is digit span memory for sequences of numbers. So what we will do is we will take some tasks that are assumed to depend on working memory, reasoning, learning, comprehension, and we'll have our subjects do these at the same time as they're holding and repeating sequences of digits ranging from 0 up to 8. So our subjects would be saying 7, 9, 6, 3, 1, meanwhile looking at a reasoning task and trying to solve it. What we found was that we'd rather expected our task to wipe out performance. It didn't. It had a very clear effect. If effect was greater, the greater the number of digits held, but errors were the same. People were just slower. And this held across all of the 3 tasks we looked at. So we reckoned that we had to complicate the picture. So we decided we'd guess on what it needed to do this, and we proposed 3 components. One was an attentional component, the central executive, and we thought that this would run the show. This was supplemented by a verbal component that we thought was what was defective in the short-term memory patients. And we argued that we probably need a visual equivalent. So we invented one called the Visuospatial Sketchpad. And then we set out trying to explore these. We were very lucky at the time that I was invited to contribute to a rather influential annual series called Recent Advances in Learning and Memory, or Motivation and Memory, anyway, Recent Advances. We were rather hesitant because we felt we don't really understand this yet, but it seemed too good an opportunity to miss. And so we wrote a paper, which came out in 1974, called Working Memory. And it's a damn good thing we did, because we still don't understand it, but it's been very influential over the years.
Alright, so you guys may have not enjoyed that as much as my nerdy self does, but it's pretty cool to watch one of the greats actually talk about how they develop something we're going to discuss in class. It's a really unique opportunity. So, when we are required to perform complex cognitive tasks like comprehension, problem solving, or reasoning tasks, we need a mental workspace to function through those tasks, and that's what we call working memory. And while working memory is similar to short-term memory, and you might even encounter someone who still believes they're the same thing, we differentiate between short-term memory and working memory by the processes taking place. Your short-term memory stores and manipulates information, yes, but your working memory is processing new information while simultaneously maintaining already stored information. So in some ways, your working memory is more complex than your short-term memory. Let's play around with your own working memory. Without writing anything down, can you mentally solve the equation below? It's pretty tough, right? To keep all the different pieces of information in your working memory while trying to solve the entire problem. It'd be a lot easier if you could write something down or plug it into your calculator. Now we're going to talk about the multi-component model of working memory, which we just heard a little bit about in our video. So the multi-component model of working memory originally had 3 components. One of these, the phonological loop, is assumed to be specialized for holding sequences of acoustic or speech-based items. And we talked quite a bit about the phonological loop and its components in the Chapter 3 lecture. So if you need a refresher, revisit that lecture and the readings. Now the second system, the Visuospatial Sketchpad, performs a similar function for visually and or spatially encoded items and arrays. Now the entire system is controlled by the central executive, an attentionally limited system that selects and manipulates materials in the subsystems. So it serves as a controller that really runs the whole entire show. Now, a major problem with the 3-component model of working memory was that of explaining how it was linked to long-term memory. So a 4th component, known as the episodic buffer, was added. So the episodic buffer is a component of the Baddeley and Hitch working memory model that assumes a multi-dimensional code, allowing various subcomponents of working memory to interact with your long-term memory. Now, since we've already talked a lot about the phonological loop, I'm going to spend more time talking about the other 3 parts of this model in detail today. But first, let's take a look at a mental exercise. So take a second and imagine that the apartment on your left, the one with the furniture in it, is your current apartment. That's where you live. You're happy there. But you have to move into a new apartment, the one on the right, the empty apartment with no furniture. Now, without drawing or writing down anything, mentally visualize how you would move the furniture in your old apartment to your new apartment. So take a second and just try to do that mentally. Did you find that difficult or easy? What was difficult about changing apartments? How do you think you were using your Visuospatial Sketchpad? Well, let's take a look. The first big key idea about the Visuospatial Sketchpad is that it is used to construct, maintain, and manipulate visual and spatial mental images. For example, Shepard and Metzel demonstrated the mental rotation effect using a simple experiment. They presented participants with pairs of 3D figures, like the ones you see here, and asked them to determine, are they the same or are they different? Various degrees of rotation were manipulated, making the task more or less complex. The second major key idea is that the Visuospatial Sketchpad operates separately from the phonological loop. Now remember, the phonological loop is assumed to be specialized for holding sequences of acoustic or speech-based items. But Logi, Zuko, and Baddeley were able to isolate the phonological loop from the Visuospatial Sketchpad. They had participants complete one of two tasks, either a visual span task in which they had to identify the missing space in a grid pattern, or they had to complete a letter span task in which they identified the missing letter in a letter list. At the same time, participants were asked to do one of two secondary tasks. They either completed a visual imagery task in which they were asked to imagine a number, or they were asked to complete a more articulatory task and complete mental arithmetic, kind of like what we did a few slides back. As you can see from the graph, the dual task performance showed that participants were allocating their mental resources to either adding or imaging almost completely. So they weren't able to allocate mental resources between the two at the same time. So for the visual span, you see they're using most of their attention to either add or look at the images. And when we look at the letter span task, we see the opposite but exact same type of pattern. So these two things can't operate at the exact same time. So the next part of the multi-component model of working memory that we're going to discuss is the central executive. So according to your text, what function does the central executive serve in working memory? Well, working memory is assumed to be directed by the central executive, an attention controller, rather than a memory system itself. So think of the central executive as the boss. The central executive could be argued the most important part of the working memory model, but less is known about it. It is the attention controller, the boss, if you will, of working memory. It's not really a memory system in and of itself. Rather, it controls other aspects of the multi-component model. So the flexibility of the central executive controls and regulates our cognitive processes. Specifically, it controls the phonological loop and the Visuospatial Sketchpad. The central executive also attends to some stimuli and ignores other, so it kind of acts as like a filter. As you are probably starting to gather, the central executive is really important for complex tasks. It employs the strategies we need to deal with problems. Although we are still talking about working memory, so we have to remember that our central executive also has a limited capacity, in that only a certain number of tasks can really be done at one time. If you're thinking about the central executive as a boss, the central executive collects and integrates information from its assistants, the phonological loop and Visuospatial Sketchpad, and from larger databases, like your long-term memory. And all of these things work together to form your working memory. So there's some concrete evidence that the central executive is very important in the working memory model. Patients with damage to their frontal lobe typically display central executive functions that are compromised. They will repeatedly make the same mistakes, like they can switch strategies or they struggle to switch strategies. So, for example, if they're being asked to sort cards, they struggle with switching between organizing them by suit and organizing them by value. They can do one or the other, but they really struggle to switch between the two. They are also distracted by irrelevant information. So again, they struggle to selectively attend to targets and ignore irrelevant information. So very easily distracted. So the fourth component of the working memory model is the episodic buffer. So a major problem with the original three-component model of working memory was how to explain its relationship to long-term memory, which is why this fourth component of the episodic buffer was added. So again, the episodic buffer is a component of the Baddeley-Hitch model that assumes a multi-dimensional code, allowing various subcomponents of working memory to interact with long-term memory. So a few things to note. It again has a very limited capacity, but this does kind of relate to chunking. The episodic buffer also temporarily holds information in integrated representations. So the episodic buffer tries to represent information in a coherent or cohesive way, not as individual just pieces or chunks, if you will. The episodic buffer also combines information from verbal, visual, semantic, all using your long-term memory. So using your prior knowledge and long-term memory, the episodic buffer is able to really bring it all together. Now we're going to watch one more video today, and this is a guy named Dr. Dolittle, not the one from the movies, and he gives a very comical kind of laid-back TED Talk on working memory in general. You'll notice a few discrepancies with some of the things that we've covered in class, but in general, this talk is right on line with what we're discussing.
So yesterday, I was out on the street in front of this building, and I was walking down the sidewalk, and I had company, several of us, and we were all abiding by the rules of walking down sidewalks. Okay? We're not talking to each other. We're facing forward. We're moving. When the person in front of me slows down, so I'm watching him, and he slows down, and finally he stops. Well, that wasn't fast enough for me. So I put on my turn signal, and I walked around him. And as I walked, I looked to see what he was doing, and he was doing this. He was texting, and he couldn't text and walk at the same time. Now, we could approach this from a working memory perspective or from a multitasking perspective. We're going to do working memory today. Now, working memory is that part of our consciousness that we are aware of at any given time of day. You're doing it right now. It's not something we can turn off. If you turn it off, that's called a coma. Okay? So right now, you're doing just fine. Now, working memory has four basic components. It allows us to store some immediate experiences and a little bit of knowledge. It allows us to reach back into our long-term memory and pull some of that in as we need it. Mixes it, processes it, in light of whatever our current goal is. Now, the current goal isn't something like I want to be president or the best surfer in the world. It's more mundane. I'd like that cookie. I need to figure out how to get into my hotel room. Okay? Now, working memory capacity is our ability to leverage that, our ability to take what we know and what we can hang on to and leverage it in ways that allow us to satisfy our current goal. Now, working memory capacity has a fairly long history, and it's associated with a lot of positive effects. People with high working memory capacity tend to be good storytellers. They tend to solve and do well on standardized tests, however important that is. They're able to have high levels of writing ability. They're also able to reason at high levels. So what we're going to do here is play a little bit with some of that. So I'm going to ask you to perform a couple tasks, and we're going to take your working memory out for a ride. You up for that? Okay. I'm going to give you 5 words, and I just want you to hang on to them. Don't write them down. Just hang on to them. 5 words. While you're hanging on to them, I'm going to ask you to answer 3 questions. I want to see what happens with those words. So here's the words. Tree, highway, mirror, Saturn, and electrode. So far, so good? Okay. What I want you to do is I want you to tell me what the answer is to 23 times 8. Just shout it out. In fact, it's exactly. All right. I want you to take out your left hand, and I want you to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a neurological test, just in case you're wondering. All right. Now what I want you to do is to recite the last 5 letters of the English alphabet backwards. You should have started with Z. All right. How many people here are still pretty sure you've got all 5 words? Okay. Typically we end up with about less than half, right? Which is normal. There'll be a range. Some people can hang on to 5, some can hang on to 10, some will be down at 2 or 3. What we know is this is really important to the way we function. And it's going to be really important here at TED because you're going to be exposed to so many different ideas. Now, the problem that we have is that life comes at us, and it comes at us very quickly. And what we need to do is to take that amorphous flow of experience and somehow extract meaning from it with a working memory that's about the size of a pea. Now, don't get me wrong, working memory is awesome. Okay? Working memory allows us to investigate our current experience as we move forward. It allows us to make sense of the world around us. Okay? But it does have certain limits. Now, working memory is great for allowing us to communicate. We can have a conversation, and I can build a narrative around that. So I know where we've been and where we're going and how to contribute to this conversation. Allows us to problem solve, critical think. We can be in the middle of a meeting, listen to somebody's presentation, evaluate it, decide whether or not we like it, ask follow-up questions. All of that occurs within working memory. It also allows us to go to the store and allows us to get milk and eggs and cheese when what we're really looking for is Red Bull and bacon. Okay? Got to make sure we're getting what we're looking for. Now, a central issue with working memory is that it's limited. It's limited in capacity, limited in duration, limited in focus. We tend to remember about 4 things. Okay, it used to be 7, but with functional MRIs, apparently it's 4. We were overachieving. All right? Now, we can remember those 4 things for about 10 to 20 seconds unless we do something with it, unless we process it, unless we apply it to something, unless we talk to somebody about it. When we think about working memory, we have to realize that this limited capacity has lots of different impacts on us. Have you ever walked from one room to another and then forgotten why you're there? You do know the solution to that, right? You go back to that original room. Okay? Right? Have you ever forgotten your keys? You ever forgotten your car? You ever forgotten your kids? Okay? Ever been involved in a conversation and you realize that the conversation to your left is actually more interesting? All right? So you're nodding and you're smiling, but you're really paying attention to this one over here until you hear that last word go up and you realize you've been asked a question. And you're really hoping the answer is no, because that's what you're about to say. Okay? All of that talks about working memory, what we can do and what we can't do. We need to realize that working memory has a limited capacity, and that working memory capacity itself is how we negotiate that. We negotiate that through strategies. So what I want to do is talk a little bit about a couple of strategies here. And these will be really important because you are now in a information target-rich environment for the next several days. Right? Now, the first part of this is that we need to think about and we need to process our existence, our life, immediately and repeatedly. We need to process what's going on the moment it happens, not 10 minutes later, not a week later, at the moment. So we need to think about, well, do I agree with him? Okay. What's missing? What would I like to know? Do I agree with the assumptions? How can I apply this in my life? It's a way of processing what's going on so that we can use it later. Now, we also need to repeat it. We need to practice. So we need to think about it here, in between We want to talk to people about it. You're going to write it down. When you get home, pull out those notes and think about them and end up practicing over time. Practice, for some reason, became a very negative thing. It's very positive. The next thing is we need to think elaboratively and we need to think illustratively. Oftentimes we think that we have to relate new knowledge to prior knowledge. What we want to do is spin that around. We want to take all of our existence and wrap it around that new knowledge and make all of these connections, and it becomes more meaningful. We also want to use imagery. We are built for images. We need to take advantage of that. Think about things in images. Write things down that way. If you read a book, pull things up. I just got through reading The Great Gatsby, and I have a perfect idea of what he looks like in my head. So, my own version. The last one is organization and support. We are meaning-making machines. It's what we do. We try to make meaning out of everything that happens to us. Organization helps. So we need to structure what we're doing in ways that make sense. If we are providing knowledge and experience, we need to structure that. And the last one is support. We all start as novices. Everything we do is an approximation of sophistication. We should expect it to change over time. We have to support that. The support may come in asking people questions, giving them a sheet of paper that has an organizational chart on it or has some guiding images, but we need to support it. Now, the final piece of this, the take-home message from a working memory capacity standpoint is this. What we process, we learn. If we're not processing life, we're not living it. Live life. Thank you.
All right, so like I said, there are a couple things he describes a little differently than how we've learned in class, but in general, I hope this really helps you bring together the entire idea of working memory as a system and its applications in real life. So specifically, the biggest takeaway I hope you have is how important processing is to our memories. So when we experience things, when we really truly process them, we remember them better. And so when we're learning, we need to try to process as deeply or as best we can. So when you're listening to lectures online, which I know is very difficult right now, I personally don't like doing it either, but hopefully you're hanging in there, make sure you're processing. Make sure you are intentional about what you're listening to. Stay focused, stay alert. When you're reading your chapters, make sure you're processing the text, that it's making sense to you, that you're not simply just skimming to get through the chapter. And when you're doing anything for any course, any situation at work, at home, in which you want to learn, make sure that you are fully dedicated to processing the information so that it has a chance to make it into your long-term memory. This gives you the best chance at learning and remembering in general. So now that we've covered the main model of working memory, let's talk about some other theories that the book discusses. So take a second and think about how Engel's inhibitory control models different from the multi-component model. Well, in general, inhibition is a term applied to mechanisms that suppress other activities. The term can be applied to a precise physiological mechanism or to a more general phenomenon, as in proactive or retroactive interference. The level of activation associated with a trace is actively reduced to diminish its accessibility, so you're unable to retrieve it. Now, Engel proposed that capacity is not about the limited amount you can hold in your memory. Rather, it's about your ability to use controlled processing. So Engel's inhibitory control model asks a couple big questions. How can we quantify individual differences in working memory? And what is the role of executive attention and control in working memory? So to answer these questions, researchers have developed and tested complex span tasks to challenge memory retention. Complex in that they are interleaving attention-demanding processing and storage component tasks. So not something as easy as just memorizing a list of numbers or letters. So the first type is a reading span or R-span test. Daneman and Carpenter had participants read aloud a set of sentences, and a set typically varied from 2 to 6 sentences. They then asked the participants to read to understand the sentences and at the same time remember the final words in each sentence. They were then asked a comprehension question and asked to recall the final words of each sentence set. So we're going to take a look at this and test your R-span. So read the following sentences and try to remember the last word of each sentence. Okay, now answer this question. Did the sailor acquire a parrot? All right, now it's time to recall. Can you recall the last word of each of the three sentences? Well, the correct answer is pet storms years. Now, similar to the R-span, Turner and Engel also developed the Operation Span Task, or OSPAN. It's a measure in which each to-remembered word is followed by an arithmetic operation. For example, apple, then the equation 7 plus 2 minus 1. House, the equation 5 minus 1 plus 6, and so on. After which, they'll ask the participants to recall the words. And this measure correlates highly with the initial sentence span task and is also a good predictor of a broad range of cognitive performance measures. And here's what it kind of looks like. So you'd see the word apple, followed by an equation. You'd see the word house, followed by an equation. And you'd do this so on and so on and so on. And you'd be asked to simply remember the words that you read. But the arithmetic problem kind of disrupts the rehearsal and your ability to keep that information in your working memory. So working memory is important because it reflects attentional control, especially when there is interference or competition. So how do researchers test the role of working memory in reducing interference vulnerability? Well, experimentally, we test the role of working memory in the following ways. We'll measure working memory capacity in one session, make groups who have more versus less working memory capacity. You then measure performance on tasks involving interference and competition in another session. And our research question would be, are high working memory spans better able to reduce interference compared to low spans? So let's do an exercise. I want you to try and remember the next set of words. And again, do not write anything down until I say so. So I'm going to give you just a second to get something out to write with and then put it away for the time being. All right, are you ready? Here's the first list of words. All right, now count backwards from the number 37. Okay, now write down the words that you remember. All right, now we're going to do another trial. Are you ready? Go. Okay, now count backwards from the number 51. All right, now take a second and write down the words you remember from that list. All right, we're going to do another trial. So are you ready? Go. All right, now count backwards from the number 142. All right, now we'll write down the words you remember. Okay, and this is the very last trial, I promise, but pay attention, all right? All right, now count backwards from the number 89. All right, now write down the words you remember. Okay, so before I show you the answers, how do you think you did? Take a second and reflect on what was difficult about this type of memory task. Was it the sheer amount of information, the order, the words themselves? Take a second and think about that. All right, now let's see how you did. Compare your 4 lists and how many did you get correct? So just take a second and remember, to be correct, it has to be in the right list. Do you have any words from a previous list that show up on a later list? For example, did you include turtle in maybe the 3rd list of animals, or maybe alligator in the 3rd list of animals? Maybe even you remembered llama for the 4th list. Well, this is a good demonstration of our vulnerability to proactive interference. This is what we just did. To test this, Kane and Engel gave participants 3 lists of 10 animals and 1 list of 10 occupations, and it was always presented last. You guys had a 15 to 30 second prevention task, then you were asked to recall each list. So asking you to count backwards was simply just something to kind of distract you, prevent you from rehearsing during that time. The theory here is that working memory helps reduce proactive interference. So thinking back to our research question, how would we expect the high working memory group to do compared to the low working memory group? Well, let's take a look. So here you can see the data for the last 3 sets of lists. Those with high working memory spans, the black bars, experience less proactive interference. The low span working memory group, or the ones with the gray bars, experienced more proactive interference. So high spans had a superior use of their attention to reduce proactive interference. So the big take homes that I want you to understand with executive attention is that people with high working memory effectively use attention to maintain goals under interference. So even when proactive interference is occurring, they're able to use attention to maintain the task at hand. People with low working memory less effectively engaged attentional processes to limit interference. So people with a lower working memory capacity have a harder time maintaining attention when proactive interference is present. So working memory accounts focusing on the number of items one can hold in memory would not predict these effects. So, in wrapping up Chapter 4, remember that you'll need to review these slides and the reading, and when you feel comfortable, take quiz number 3, which is due Sunday by 11:59 p.m. You need to also make sure that you complete discussion board number 4 by Sunday at 11:59 p.m. And you're going to want to finish up, because I'm hoping you've already started, your research assignment. The very first one, numerical memory, is due this Sunday at 11:59 p.m. So let's talk about the discussion board a little bit. So this week, the discussion board asks you, how do you think knowing a student's working memory capacity could help a teacher adapt their instruction? Now, I'm not going to say too much here because I really want you guys to think critically about this and how it relates to what we just discussed with proactive interference. Maybe even going back and watching the Baddeley or Dr. Doolittle videos will help refresh your memory and give you a better understanding of how you should answer this question. Okay, so research assignment results. Now we're going to talk about the results of the numerical memory experiment. So, like I said, you don't have to include any of the design or statistical information in your paper, but I just want to go over it because I teach and I love stats and I'm an experimenter. So in this case, we had a within subjects design, meaning that all of our participants completed both levels of the IB. So when you did that experiment, you participated in both the visual and the auditory conditions. And that's exactly what the independent variable was, stimuli type, either auditory or visual. Then we had our dependent variable, what we measured, and that is the length of the digit sequence remembered. So thinking back, you had to remember a certain sequence of numbers, and I can't remember how large it gets. I think it gets all the way up to 20 at some places. How many of those you were able to remember correctly would have been the dependent variable here. So I, not y'all, you're welcome, ran a paired samples t-test to determine if there was a difference between the length of the digit sequence between auditory and visual numbers. So we want to compare how everyone did in both groups. The t-test revealed that memory of visual stimuli was greater than memory for auditory stimuli. Let's take a look. So I graphed this out. As you can see, that is the rate remembered plus or minus the standard error of the mean. And the visual group had much better recall or much better performance than the auditory group. And this is a significant difference. So the auditory stimuli was not remembered as well as the visual, and the visual stimuli were remembered better than the auditory. Was this what you expected? Did you think seeing or hearing would be more easily recalled by participants or by yourself? So bringing it back to what we've learned, why do you think memory for the visual stimuli was better than for the auditory stimuli? Why do you think the visual stimuli was more easily or correctly remembered than auditory information? How does this maybe relate to sensory memory or working memory? And how do these findings relate to the phonological loop and the visuospatial sketchpad components of working memory? Think about how the phonological loop works. Think about how the visuospatial sketchpad works. Think about how your central executive uses attention to allocate resources to the task at hand, like the digit span test you did. How do you think all of these things combined contribute to the results that we found? So those would be some really good places to start with the discussion paragraph of your report. And just as a brief reminder, the report requirements are simply a 12-point Times New Roman font, double-spaced, one page, so nothing too long. I want you to just report what you did and why, so go back to that introduction that we went over last week, read up on it. Why is it important that we do this experiment? What did you do in the experiment? What did you find? No statistics or anything. You can simply just say, this was better remembered than that. Discuss how this relates to what we've learned in class. So those discussion points I was talking about. All materials that you need are under weeks 3 and 4 in eCourseWare. You've got the summary and kind of introduction last week, and then this week, everything I just showed you is in a Word document for your convenience, so you can use that however you see fit. Feel free to reach out with proofreading, questions, help. I know this is the first one, so if you guys simply want to send it and say, hey, am I on the right track? I'll try to give you some areas for improvement or let you know if you need to be heading in another direction, but I'm always here to help you guys with anything that you need. So if you have any questions in general about today's lecture, about any of the materials, or about the research assignment, feel free to reach out and have a great rest of your day.